Welcome to Tomorrow Makers, where we explore how we learn, live, work, and play now and in the future. I'm Carlos Ramos.
And I'm Summer Beatty.
Hey, Summer.
Hey.
So we've got this episode that got lost in the space-time continuum.
Oh, don't even go there.
Well, I think we recorded it last week, but then it took off so fast that for us, it's been months in the waiting. I don't understand it. Dave Richards does. We tried to talk about it, but I sounded like I don't even have a word for what I sounded like.
I said, thank you for cutting that out. I felt very uneducated after listening.
Yeah, we had to pull Summer out from the corner. She was shivering, shuddering off to the side. No, it was all good stuff. But yeah, some stuff hit the cutting room floor, but what is left is really great. Do you want to talk about it?
Yeah, sure. So this episode came about because we came across this beautiful astrophotography, and we learned that it was actually created by one of our graduates who now works at Penn College. So it was an excuse to get him on the podcast and just pick his brain and ask him, how does he create these beautiful, beautiful photos? And then we also have Dave Richards, who is an astronomy and physics instructor here at Penn College, to lend that perspective. So it was a really fun conversation.
Yeah, and some things have developed since. So Brian Schaefer, one-time student, is now...
He is on faculty. So he is a CNC and machining and automation instructor here at Penn College. So
good. A lot of good stuff. Why don't we just get into it?
All right, enjoy. So we're here today with Dave Richards, physics faculty, and Brian Schaefer, Penn College graduate and maintenance mechanic millwright specialist. That's a mouthful. So you're working here on campus using your degree from Penn College, which is really cool.
Yep.
Yeah.
Degree? Isn't there like a whole litany of degrees that you...
How many do you have? 3?
I have 4 from here at Penn College. Yeah.
Oh my God. Did you earn one since I looked it up last week?
There's 3 degrees and a certificate.
Okay.
So
that counts. That's awesome.
All right. So what are they?
So one's in automotive, an associate's in automotive. One's automotive service tech. That's the certificate. I have an associate's in machine tool technology and a bachelor's in applied technology studies.
And then, Dave, you're here for physics, so why are you guys even in the same room?
Well, I teach both physics and astronomy here, and Brian was one of my students in physics and astronomy, and he took the astronomy lab, so I've had him for three semesters and got to know him pretty well, and I'm really impressed with his photography. He's an incredible photographer when it comes to astrophotography, so I'm here to kind of talk it out.
I'm curious, how did you end up in physics? How did you end up in astronomy? What led you to this career path, Dave?
When I was in college, I had a really good professor who explained things very clearly, and he just explained how nature works. And I was always interested in how things work, you know. So when I started off as a chemistry major, and then I switched to English, and then when I had physics, I decided that's what I wanted to do. I wanted to be a physics major. And so I did that. I got my master's from University of Alabama and my bachelor's from Mary Washington College in physics. And then I got lucky and I got a job teaching at a 4-year liberal arts college after I got my master's degree. And teaching is a whole different realm, but I really enjoyed it. So I finished up with my PhD here at Penn State in instructional design. But yeah, it's been a long road, but overall, it's been a great experience. I mean, physics, to me, explains the rules of how nature works. And I like life as a game, and that's the rules of the game. So I've always been interested in that.
So you were probably surprised when off air, or maybe Carlos will salvage some of that information. I'm asking these very elementary questions. So when you talk to students and people who don't have a grasp on physics, are you thinking, how are they just operating on a regular basis and they don't understand how this stuff works?
No, I have kids. I know it's tricky. It takes a long time to understand these concepts. It's not something you learn quickly, and you have to hear many times. So no, I understand these concepts are not easy to understand. It takes time. That's what the educational side of things, that's how you learn. You got to keep pushing yourself.
And so you had Brian in class. And I think some people who might be thinking, okay, we're recording here on the College of, Pennsylvania College of Technology. And he has, with his programs, had an opportunity to study things like astronomy and physics. And did you take photography too?
I did.
Okay. So I think some people might be like, what? Somebody can do all of that. What was that like? How did you, Brian, like when you came here, were you planning on taking those classes? How did you make those choices?
When I originally started here, I just came for automotive. That's what I thought I wanted to do. So I came here, got my associates, and I actually didn't take any of those classes under those degrees. It wasn't till I started taking my machining degrees, met my future wife, we decided to take this photography class. That's kind of where some of it started. I had a DSLR that I didn't really know how to use, so I wanted to take this class, kind of get a better idea how that worked. And then when I came back from my bachelor's, I needed a physics with lab class. I think that's or a science with lab. That's how I got into the astronomy class. So, and then physics was required too. So I had a great time in Dave's class. He's great at what he does.
So how did you take all of those and combine them to do astrophotography? Did that all happen kind of here when you were at college? Like you took the astronomy piece and you took the photography piece, or were you doing that before?
So honestly, the astrophotography kind of started before. I was in college, but it wasn't all related, sort of. I had a telescope and I saw these pictures in magazines and stuff. So I kind of wondered if I could take them. So got an adapter, put my Nikon on my telescope, and the first image I ever saw of like the Orion Nebula, it was just like, wow, I took that picture from my driveway, just one shot. And it wasn't a great picture, but it was just amazing to see that it's possible. So that's kind of what it got started for me.
And how long ago was that?
That was 2010.
Okay. So you've been doing it for a bit.
Yeah.
Okay.
I didn't really get serious into it till probably 2018, 2019.
And you do share your photos on your own social accounts and things like that. But do you have a website where you...
I don't have a website, no.
Okay.
I thought about making one, but I just never got into it yet.
Colors are amazing. When I first saw one, I was like, where can I get one for my wall that the blues are so beautiful?
Thank you.
Where does that blue come from?
So the blue color comes from oxygen. So if you can correct me, Dave, but the stars in that area are ionizing that oxygen, right, Dave?
Correct. Yep.
So, and then that's emitting that blue color.
Still student and teacher situation here. He's looking for confirmation. I love it.
But I'm sure that's got to like enrich that hobby to say, well, I know why it looks the way it does.
Yeah.
Whereas me, I can just go up and say, like Summer, oh, that's a pretty blue. That's really nice. I really love how those colors are interacting. And for us, it looks like a cloud of gas, but it is more than a cloud of gas.
Yeah. And a lot of the nebulas you see are probably going to be all the same color because they're mostly made of the same gases. You got hydrogen and oxygen mainly, and sulfur. A lot of them are all going to be the same colors, just different amounts of each color.
And the reddish is the sulfur, the orangey.
Red is sulfur. Hydrogen is red.
My students look through the telescope to see things. A lot of times you don't get the colors just through a visual. So you do need filters, usually you're processing to get those colors to really pop.
Yeah, so like Dave said, a lot of these targets are so dim that your eyes can't pick up the color if you were to just look at them through a telescope. So what we do is we take a lot of small exposures and we actually stack those to get a nice clean image. So every image you take has noise in it. So you want to take a lot of exposures over a long course of time, stack those to get rid of that noise. Then you can start brightening things up and making sure the colors are right and that kind of stuff. So a lot of these images you see wouldn't look like that through a telescope. They'd look kind of just like a fuzzball in the eyepiece. They wouldn't have any color to them, really.
You have to take these photos over time.
Correct.
Things are moving. It's not like you can just point your telescope there and say, okay, click.
Yep.
How are you dealing with that?
So a lot of the mounts you get, telescope mounts you can get have motors in them that are calibrated to the rotation of the Earth. So when you set that telescope mount up, you have to do what they call polar aligning it. So you have to align the rotational axis of that mount to the polar axis of the Earth. And then that'll get you close, but then they have what they call auto guiding. So your telescope actually has a second telescope and a second camera on it that locks onto the stars and can make small corrections to that tracking.
This is not an amateur situation here. I feel like you need to know quite a bit to just get into doing these things.
There's a lot of information, a lot of good information out there on this stuff. So there's a lot of programs that make it very user-friendly.
Okay.
So they've taken a lot of the in-depth knowledge out of it where you can kind of tell it what you want to do and it does it.
So if I want to get into this, I just need a DSLR. I need a telescope. I need something to connect the DSLR to the telescope. And then I need some software.
Correct. And you can get into it with, they call it a tracker. It's just a single axis. They're relatively cheap, like $200-$300, that you can put your DSLR on and just use a camera lens. And you can take Milky Way pictures, like wide field stuff with that. And they work really well. You can get into it budget friendly too, but that opens up the rabbit hole for all the bigger telescopes and bigger mounts and cameras. And
you brought with you a prop. We're not using video today, but do you want to tell us what you brought with you?
So I brought with me it's called a Crayford style focuser that I designed and built myself. So a Crayford style focuser relies on like a central tube that's sitting in bearings, and there's no gears or anything in there that makes this work. It relies on friction. So there's no what they call backlash. So anytime you have gears, when you change directions, there's a small gap in those gears. And when you change direction, it kind of introduces error into it. So this style focuser, being that it's friction drive, has no backlash. So I can actually put a motor on there. I have one at home, and this will automatically focus. So it'll take several images at different focal points, and it'll pick the best point out of those and go to that point, and it'll be perfectly focused.
It's really cool. And he was saying that, I said, is this something you could just buy? But I know he's all about making solutions instead of buying them. And if you could see it, it's a work of art. He's chosen different materials for the screws and this other knob in the front, just so it's copper and aluminum, and it looks very sharp.
Thank you.
So how did you get into just deciding, I'm going to make this? I'm not this particular piece, but just in general, because I feel like that's something you've shared before, where you're somebody that wants to make a solution instead of go to the store and buy it. What's the thinking behind that?
Well, a lot of it's kind of budget driven. I'd rather, if I can save money and make it myself, I'd rather do that. And a lot of times you can make it better, making it yourself. You can make it exactly how you want it. I kind of got a lot of that from my dad. He makes a lot of things in his garage. He has a milling machine and a lathe, welders, that kind of stuff. So I kind of grew up in the garage with him. So we were always making stuff, fixing things. Just that's kind of how I got started in that.
Yeah, it's natural progression.
Yeah.
Then is that why you kind of got in? Does he also do automobile work?
Yes.
Because you came for automotive.
He was actually an instructor in automotive.
Oh, okay. Okay.
So that's kind of how I got into automotive. I figured, but both my brothers did that too. So I was like, that's what I'm going to do. I'm going to be a mechanic. So I went through that program and I did it for a while. And I also wanted to do machining too. So I ended up switching to machining and then ended up starting here. With
what you're doing here at Penn College, do you have an opportunity to use that skill set to make these solutions too on campus here?
Oh, absolutely. So a lot of machines, well, not so much anymore, but before we renovated our shops, we had a lot of older machines that parts weren't available for. So I could take a part and reverse engineer it and make a new part. And whenever I did that, I would always keep a blueprint on file. So if I ever had to make that part again, I have the 3D model, I have the blueprint, I can just go back and make it, not have to reverse engineer it twice.
What was your starting point?
I looked at pictures online of how they worked and then just started in CAD software, just started building things, assembling them in there, getting all my clearances right, make sure there's room for all that stuff to fit in there. And then just got blocks of material and started machining it out.
It is beautiful.
Thank you.
So Dave, you never wanted to get into astrophotography or anything like that?
I have not gotten into astrophotography. I do a lot of visual looking at the stars, and but it's something I've always wanted to get into. I've taken pictures with my iPhone, and it doesn't do it justice. But to set up, it takes a lot of time, a lot of commitment, and as Brian said, money. And so I've not really gotten into that hobby. I've had a few students in the past that have really gone down that rabbit hole, and I've worked with them. In fact, James DiPaolo. I had him in 2010. He has his own observatory near Picture Rocks, where his whole garage roof slides off. And he's been doing astrophotography for many years. And I used to take my students over there, and he would show them his setup. It was pretty cool. So I'm hoping I can do that with Brian as well when I teach the lab again, because it's nice to have past students come in and explain the photography side, because some students do want to do that. I've never gone down that path.
Yeah, I'm glad you brought that up, because I think a lot of times we talk a lot about how, Penn College is a hands-on institution. And so we have many people say, well, how does that translate into something like accounting, or in this case, physics, astronomy? But you're taking students out of the classroom into these, so they're actually getting to look at stars and, see this real life situation and see everything come to life.
Yeah, the college, we have 4 8-inch Schmidt-Cassegrain telescopes, and we have a 14-inch Schmidt-Cassegrain telescope. And so we take those out. And we used to have a place called Morgan Valley up on a mountaintop. And for about 20 years, I used Morgan Valley as my observatory. And we would go out on the deck there and observe the stars and galaxies. And that was incredible. Unfortunately, the college has sold that since then, but we still go out. And so at least try to get out at least half the time in the lab to do night observations. So we have to have a night lab. So we usually do them from 6:30 to 9:30 at night. Again, that limits the time to set up the scope. So astrophotography is not really something I can get into too much, because it takes a lot more time than that. But it's a great experience. Many students that haven't seen anything through a telescope, they're just awestruck when they see Jupiter or Saturn's rings for the first time. And it's cool to see that expression and the excitement. Yeah, so that keeps me going. I really love teaching the astronomy lab.
You had said about having students see just their eyes light up. I'm sure this is a first for many of these students, seeing some of these things. And it's cool to tie in that technical aspect with just having that well-rounded vision of what exists in the world.
We get lucky sometimes. One night we saw the Northern Lights up at Morgan Valley, so we could see that. And it depends. It's weather dependent. It's very frustrating because you have one day a week to go out observing. We do labs in the lab as well, but we try to go out observing as much as possible, because that's what the students want to know. They want to know the constellations, the stars, be able to look through the telescope and see things. Looking on a computer screen still isn't as real as looking through an eyepiece and seeing it for yourself.
So if you're not going to Morgan Valley, what are you using? Where are you guys going?
We've been going to the Earth Science Center.
Oh, okay.
There's a darker area there where we can set up.
That's still nice. I was thinking, is Ryder Park a good...
Yeah, but we try to keep the stuff on campus because some of the equipment's big and heavy and cumbersome. So it's better if we can keep it on campus and then get it out instead of having to lug it everywhere.
That makes sense.
Now, Brian, you're not constrained by having to be on campus. You're not towing a bunch of students around with you. Where are your ideal locations for doing this?
So most of my work is actually just in my driveway in Avis. But if I go off site, it's usually up to Cherry Springs State Park. They have an overnight field up there. So you pay, I think it's $15. You can park, set up your scope. They have nice power outlets and everything there, Wi-Fi, and you can just spend the night there. And it's super dark. So that's one of my other favorite places to go.
And that's about as dark as it gets within driving distance, right? For a day's drive.
Yeah.
Well, it's really the darkest skies in the Northeast.
Oh, really?
Yeah, it's pretty famous for, they have a star party there once a year. It's hard to get a site, but I've done that before. And people from all over the country come to set up their scopes.
Wow.
And it's nice because you can you just walk around and you can look through everyone's scope and see different things. A guy had a chair with binoculars set up, and you can sit in the chair, and he had a remote control that you could control the chair to look at whatever you wanted. So it's a really phenomenal experience. If anyone gets a chance to go to Cherry Springs, I've gone up there with friends and taken a scope with me to look at the sky. It's good. Yeah. They do a good job of keeping the light pollution low. So the surrounding towns usually have light shields on their lights to reflect the light back. So it's not trying to minimize the light pollution. So
that's not too far from campus, right? It's few
hours.
About
an hour. It's an hour drive.
Oh,
it's not bad.
That's very fortunate.
Right. Putting it on my calendar now.
Well, you might need to make reservations for a year in advance, right? I feel like it is.
Well, for the Star Party, but you can go up there any time of the year.
Yeah.
But the Star Party is usually 1 week out of the whole year. And they have speakers that come in, and during the day, you can, if you're not sleeping, you can go ahead and go to these talks. So it's a phenomenal event. But like I said, it's kind of hard to get into. You got to be quick.
You mentioned going to the Earth Science Center, which you do have the mountain range between Williamsport and that site. So we don't have as much light pollution as being in Williamsport, but then you're starting to get closer to some other towns to the south. How are you mitigating as much of that light pollution as you can to, and Brian, for you, for where you're taking your photos, because in Avis, you're still dealing with Williamsport on the horizon, Lock Haven on the other side, Jersey Shore's right there.
Yeah. So being that I'm doing imaging, I just wait for whatever target I'm going to be imaging to be above a certain elevation. So, I mean, I usually just kind of give it a visual, see where that light, they call it a light dome, see where the target's at in relation to that, and then just try and make sure it's above that. So the higher the elevation of your target, the better you're going to be.
Ideally, we would be able to go 20 minutes outside of Williamsport. We still have some light pollution. You just have to deal with it. For deep sky observations, looking at, galaxy or nebula, you really want as dark a sky as possible. But even if it's a full moon, a lot of people think, oh, that's a great night to observe, but that's actually the worst because of the light pollution from the reflection of the sunlight off the moon. So ideally, you want a new moon phase and try to get away from that light pollution. But if you're looking at the planets or any bright object, it's not that detrimental.
Depending on what target you're imaging, if you're doing imaging, they have what they call narrow band filters. So what that does is it blocks out most of the light except for small bands of that spectrum. So the nebulas that we talked about earlier, the oxygen and the hydrogen, it'll pass the wavelengths for those light, but block most of the other light. So you can kind of use filters like that too to help in those situations.
You can't use your cell phone, you said. It's definitely not. There are no apps or anything like that will...
There are some, but they don't give great results.
Yeah, okay. Yeah. Well, it makes what you're doing so much more special, though. Not only can you not see it with the naked eye, you can't easily achieve that. So It probably feels really great to see that. Do you print them? Do you have any canvases at your house or anything like that?
I've printed a couple, but I've never done anything large scale.
Massive.
Yeah.
Yeah, that would be really cool, over a fireplace or something.
It would be cool.
Yeah.
Yeah, I always wanted to take a really wide field image of the Milky Way and just put it on the ceiling. I think that'd be cool.
I'm thinking we got to do some environmental art in your area, Dave.
Yeah, that sounds great. I mean, honestly, when you look up in the night sky, it is magical. A lot of people don't do it as much as they used to, obviously, because of the light pollution and being inside more. But there have been times, one time I was on when I was younger, I went to Greece and I was on an island and I looked up and it was like diamonds in the sky. It was incredible. Per pitch black sky, no light pollution, and it really is a moving experience to just lay there and look up in the night sky and see the stars and to know the history and what's going on. And it's really special once you have the knowledge base and the education behind it. It makes it much more special because you understand what's going on and you can kind of visually take it all in and understand a little bit how the universe works, just a little bit. We still don't know a lot, but...
Brian, you had Dave for 3 classes. I don't think even in major, I don't think I went through 3 classes with any of my professors when I went to school. Why did you choose Dave 3 times?
I liked the way he taught. I liked the experiments he did. I just enjoyed his classes. So anytime I saw a class that I could take with him, I took it.
And it was nice to have him in the class for the lab portion, especially because he had experience with scopes where many students don't. So it was a big help for me because he had his group and he could explain how things work. Because I tell my students, I show them how a scope works, but they have to align it themselves. And we do a 2-star alignment to do a quick, you can do multiple alignments, but it's important for the students if they want to continue and get their own scope to know how to set it up and how to do an alignment to get the gears working properly to track the objects in the night sky. So it was nice to have him in the lab because he was able to, with his life experience of doing astrophotography and knowing how to work a scope, it was really a pleasure to have him in the class.
Do both of you travel? Do you have any travel experience where you're going somewhere and you're taking, maybe you had said about Cherry Springs, but are there any locations when you travel where you're thinking like, oh, I'm going to be in a prime spot to, Brian, either take a photo or Dave to just look at the night sky? Does that factor into your vacation?
It hasn't in the past, but I've definitely thought about it. And I've definitely been in situations where I wish I had my equipment, but a lot of the stuff I have is too big to lug around, especially when you have all the other stuff for vacation with you. So
yeah, it's not like you can just rent one at the airport, like a GPS. Just set a telescope in the back.
Yeah, same. I traveled a little bit when I graduated from college. I did a 2-month Eurail pass. And so we went to the Greek islands, as I mentioned. And it really is, like I said, a moving experience to be away from the light pollution out and just see the night sky in its glory. And it's really incredible to just get out there. I would love to go north. I was in Alaska, but it was the summertime, so that's not the best time to see northern lights. But I'd love to go closer to higher latitudes to be able to see the northern lights. But yeah, I don't really have a set destination like in my mind where I want to go and do astrophotography.
Gotcha. Dave, since I don't know you very well, I know do you have any hobbies?
I do brew beer.
Okay.
So I started a homebrew club with 4 other people in 2012. And so we have the Billtown Brewers Guild. We do a lot of charity events. We do the Tabor event coming up here in August. We've been doing that since the start. It's called Bottles and Brews. And we give away our beer, but I also helped to start the Brewing and Fermentation Science program here with Justin Ingram before we hired Tim Yarrington. So that was kind of we got that ball rolling and figured out what we needed to do. Justin Ingram did the heavy work there, and then when we brought Tim Yarrington on, he took over, and that's been a great program. So, but yeah, I have hobbies, but they're not necessarily related to physics or science.
It's fun that science can be used in so many different ways, right? It's just, it's everything.
Yeah, brewing is a very creative scientific process. Tim will tell you all about it, Tim Yarrington. It's incredible. I mean, it's the foundation of how nature works, like I said. So it's really important for technology. That's one of the reasons, I wanted to come here to teach is it's applied technology, uses physics constantly. It's the foundational part of that, any program really. So, and the Penn State affiliation. So I've been here 30 years next year. I started in 1995. So I've enjoyed it here.
Wow. It's hard to believe looking at you that you've been here for 30 years. So are you from this area or did you exclusively come to Penn College for?
Well, I grew up in Lancaster, Pennsylvania.
Okay.
That's where my hometown is. I went to school in Virginia and Alabama, but I was working in Alabama at an all-women's college, a female college, for a couple of years, and I saw this job opening. I wanted to come back to the Northeast. I really, I want to be closer to my brother, sister, and parents. So when this job became available, I was lucky to get it, and I've been here since.
Yeah, it's such a cool area. We don't talk much about Williamsport, but I feel like we have a lot to offer here.
Oh, definitely. Yeah, I love the area. It's beautiful, the biking, the trails. It's nice to see, like I said, some of these breweries popping up and lots more things to do outside. You can go out biking, hiking. It's a beautiful area.
Yeah, we're right on the Susquehanna, so there's, the waterways, and we do talk a lot about we love to be on the trails and be outside, and so we've covered that.
Dave, you've been here for 30 years teaching physics. Penn College is a hands-on institution. Any college says they're hands-on, but Ryan, maybe you can talk about exactly what hands-on meant to you at Penn College, and then Dave, how do you deal with hands-on in physics? You've talked a little bit about the astronomy, but how about in the physics itself?
I'm definitely a hands-on learner. So when it was automotive, you're taking transmissions apart, putting them back together. You can talk about that all you want, but until you actually do it with your hands, you're not going to learn a lot of it. Same with milling machines and lathes and that kind of stuff. It's like riding a bike. You can read about it. You can watch videos about it. That's not going to help you ride a bike. So you need to get out there. You need to get your hands on the equipment and use it and just make mistakes. And, if you're not making mistakes, you're not going to learn.
Yeah, same with physics. We have, every physics course except for one has a physics lab. And the lab is the hands-on side of things. The lectures we do little projects in the classroom to get students, active, but the labs are really important. That's why I'm not a strong proponent for some courses online are difficult to teach. And physics is one of those because you really need kind of expensive equipment, but you want the students to do these experiments, as Brian said, learn from their mistakes and see it in real life.
What's your most memorable hands-on experience here?
My first class here at the college was my dad's class. So getting in the lab and getting your hands dirty, taking this stuff apart and putting it back together. And that's just probably one of my best memories of college.
And Dave, a similar question. What moment can you reflect on in the last 30 years that have said, yes, this was the place for me?
Well, we have a makerspace now, which is incredible. I've been taking students down there to do some labs. We do a tensegrity table where they build their own table. And they can look at the tension and the torque, and they can analyze it from a physics perspective. But then they have a little kind of cool object that they can put on their desk, So, but I think over the last 30 years, I've seen a lot of changes at the college. But our physics program, they've always been very supportive on getting the equipment we need. We do some really interesting labs, especially in second semester, where some of the equipment's very expensive. We calculate the mass of an electron. We look at electron beams. That's something you can't get easily. You have to invest money and time and create labs that allow students to experience how to force an electron beam to bend, using magnetic fields. And that applies, a lot of people say, well, how's that apply to real world? But they have electron beam welding equipment here. They have an electron beam welder that's very expensive, but it explains the physics. How can you bend a beam of electrons to go where you want it to go? I pride myself in developing some of those labs, getting some of the equipment over the years. We've gotten grants for telescopes. We've gotten Pennsylvania grants for some things. But the school's been very supportive for getting the equipment we need to do the best job we can at teaching.
If you had one parting piece of advice for a student?
My advice for an up-and-coming high school student would be to try to get as much math and science background as possible. Now, not everyone's into math and science, but when you're in a technology field or you're going into a technological education, you do have to rely on the science and math for much of what you're going to learn. So if you're coming here, if you're going to major in a technology, I think that's probably the best thing you can do for yourself is to become strong at the math and learn as much science, chemistry, physics as possible, because that'll give you a strong foundation to start here and really excel.
What are ways that students can strengthen those skills if they're not getting what they need or how they need to get it in their high school?
There's a lot of stuff online to help you, but you can also, depending on what kind of summer jobs you get, look for jobs that might be working at, some type of technical field, automotive or something, where just push yourself a little bit outside your comfort zone and maybe try to do something almost like an apprenticeship during the summer. When I was in college, I worked at Black & Decker fixing power tools, and I didn't know anything about power tools and how to fix them. They kind of trained me on it. But that gave me an introduction into basic circuits and brushes and armatures and motors. And so that experience helped me when I got into college because I was working with that kind of equipment. So when I got into physics, I understood what an armature was or a motor or field, switches, So it helps to try to push yourself outside your comfort zone and learn new things. And from that, you never know where it'll take you. So.
Don't be afraid to try things. You don't know what you're going to be interested in if you don't try it. Get a summer job, see. It doesn't matter where it is, really. Get a shop or a job cleaning at an automotive shop, see what they do, or a machine shop or something along those lines. You don't know what's out there if you don't go experience it. So
that's perfect.
Great.
Good note to end on. Get out there, explore the night sky, new opportunities, new jobs, whatever it might be. Thank you.
Thank you, Brian. Thank you, Dave.
Thank you.
Thanks for hanging out with us today.
Don't forget to rate, review, and subscribe wherever you listen to your podcasts.
Check out our show notes for bookmarks to your favorite sections and links to resources that we mentioned in today's episode.
You can also find past episodes and see what's on deck for upcoming ones at pct.edu/podcast.
And of course, we are open to your thoughts, ideas, and suggestions, so send those over at podcast@pct.edu.
It's been real.
Catch you next time.
Is that better?
Did that actually fix it or just make it so I can't hear it?